Good morning, everyone. I am Sri Vaishnavi. My roll number is 24011805338. My guide teacher is Raju sir. Now I am going to discuss about auto transformer. Let me introduce it to you. Generally, a transformer is a static device which converts the electrical energy from one circuit to another circuit either by increasing or by decreasing the voltage. Here, general transformer contains two windings which wound around the core, but in this auto transformer, there is only one winding, and the same portion of winding is being used for the primary and the secondary winding, and it is common for the both. So, it is also known as voltage regulator or variac, as it helps to regulate the voltage when it is needed. The basic principle involved in this auto transformer is electromagnetic induction. So when there is a change in the magnetic field around the conductor, then the EMF is induced in it. So when we connect this auto transformer to the supply, then the current is passes through it. It produces the magnetic field. So change in this magnetic field produces the EMF, and hence it can be transferred from one circuit to another circuit. Coming to the construction, generally this auto transformer winding, it is single winding and it consists of three parts: primary winding, secondary winding, as well as tap point. The entire winding is connected to the input. That means here AB in this picture, AB is primary winding, which contains a number of turns N1. Secondary winding is the portion between the load and the number of turns are N2 in the secondary winding. Tap point, we have to take the tap point on the winding so that we can get the desirable voltage. And generally, this is the conventional transformer and the auto transformer. In the conventional transformer, there are two windings, and these windings are electrically isolated but magnetically coupled. Whereas in this auto transformer, there is only one winding and they are both magnetically and electrically interrelated. This is the main difference between conventional and auto transformer. Coming to the brief details of this auto transformer, here we can see that AB is the total primary winding as it is connected to the input voltage V1, and here the output voltage is V2, and the current flowing through the primary winding is I1, whereas the current flowing through the load is I2. N1 are the number of turns in the primary and N2 are the number of turns in the secondary. Coming to the working, secondary voltage is taken from the tap point along the winding, and the amount of voltage difference between the primary and secondary depends on where the tap point is. And here the voltage ratio between primary and secondary, it means that the transformation ratio determined by the ratio of length of shaded winding to the total length of winding. There are two operations of this: step up and step down operation. In step down application, the secondary voltage is lower than the primary voltage. It means that the number of turns in the secondary must be less than the number of turns in the primary, such that when the voltage is converted from one circuit to another circuit, we can step down the voltage. In the step up application, the secondary voltage is higher than the primary voltage. It means that the secondary number of turns must be higher than the primary number of turns. Copper savings. Generally, in a conventional transformer, we use two windings around the core. As we can see here, in the auto transformer, there is only one winding present, such that less copper is required. Here, transformation ratio is the turns of the secondary by turns of the primary, or secondary voltage by primary voltage. Saving of copper can be defined as the amount of copper used in the conventional transformer minus amount of copper used in the auto transformer. That is transformation ratio times amount of copper used in the general transformer. Coming to the efficiency, auto transformer is highly efficient when compared to that conventional or two winding transformer. Sometimes it may reach 99% efficient in some conditions. Efficiency is given by the equation P output by P input into 100. There are many advantages of these conventional auto transformers. Efficiency, as I told, it is highly efficient when compared to those two winding transformers. Compact size. This requires less size and space, lower cost. This is cheaper when compared to those general transformers. Better voltage regulation. So particularly when we need small voltage changes, it can be used. Disadvantages. Limited voltage conversion ratio. It means that it cannot handle any large voltage differences. There are also safety concerns as the winding is connected electrically and magnetically. So there may be a risk of electric shock. Low isolation. Less electric isolation is between the primary and secondary circuit. So it is also causes some risk. There are many applications. It is used in starting motors, voltage regulation, electrical distribution, variable voltage power supplies, and also electrical furnaces and HVAC systems. Let me conclude my PPT by this. Auto transformers are used in different applications, and it also reduce energy loss and provide cost effective voltage conversion. So due to the reduced size and cost, and they have more efficiency, these play a critical role in the modern electrical systems. And also it is used now widely in the industrial as well as commercial applications. Thank you.